Did you know you can use your calculator to find the derivative? What? Okay, this isn't one of those times where you're like, what, we've been doing it the long way and I can just use my calculator every time? No, it's not like that. It's not like you can just use your calculator all the time to find the derivative. The only thing that the calculator can do is it can find the derivative at one point, or it can graph the derivative. But if I put in a function, it can't spit out the derivative for me. It can't just spit out the function that is the derivative. It will graph it for me, or it will tell me the value at a specific point. So it'll tell me the slope of the line at a very specific point. But here's how you do it. There's two different ways actually to do it. We can use it in the calculate menu. You know, when we calculate zeros for a function, we can do it there. So I'm going to show you that way. But this is not the preferred method. This one honestly doesn't work as often as the other ones do. You know, a lot of times you need something different. So here I go. I'm going to go back to Zoom 6 so I can see this function better. So here's my function. I want to find the derivative. I'm going to go to second calc. And look, now you know what that means. You guys have probably seen that all this time and never even knew what it means. So we go to the derivative, and then it asks where do you want to calculate the derivative, and you can just type a number in and push enter, and it'll tell you the derivative when x equals 2 is 21.887. But this is not the best way to calculate the derivative. In fact, it's not something, like I said, it only works some of the time because it's accurate, but a lot of times you need something different. So there's a couple different things we can do. The other way we can do it is we can actually use the math menu. So you go to math, and you come down to n derive, and look, here's a derivative. If yours does not look like this, then you need to come to me and I will update your operating software, because if you're going to hate your life if you have to type it in. There's a way that you have to type it in very specifically, just as n derive in some parentheses. So hard. So we're doing the derivative when with respect to x of what function are we doing? Well, we already have our function in y equals, right? Our function is y1, isn't it? So we don't have to retype the function. We can just go into our calculator and bring out y1. So we go to vars, right here. We go over to yvars, and we say function, so number 1, enter. And it asks, which function do you want? And I want function y1. And look at that. I don't have to retype it or anything. And then it asks, this is the function of y1. And this little bar means evaluated at. And what do I want to evaluate it at? Well, in our notes, we want to evaluate it at 2. We push enter, and we get 21.8875. Okay? So that's the other way to do a derivative. One more way to do it is to graph the derivative. So if I have this function here and I want to graph the derivative, I can just get down onto another y equals, and I can go to the math menu, and I can go down to n derive, and I'm going to say I want to graph the derivative with respect to x of y1. So I'm going to go into vars, yvars, function y1, when x equals, get this, x. When x equals x, because now it's going to graph the derivative for the entire function. So here I push graph, there's the function, and there it's its derivative. And we know that that's its derivative, right? Because the x cubed, it's an x cubed, well, it's 3 to the x, so we don't know exactly how to do that one. But it's a cubic function originally, so now it becomes a quadratic function. Okay, so then, oh, and the other way then, if you wanted to find the derivative at a specific point, we've graphed the derivative. Now I can actually find any value on that derivative at a specific point. So I can push trace, and right now it's tracing on the blue function. That's not what I want to do. I want to trace on the black function, and I can put in 2, and it will tell me the value of that function at 2. So that's the value of the derivative at 2. Bam, 21.887. So those are all the different ways that we can do the derivative in a calculator. Okay, so let's look at another one. It's yet another one that we don't know how to derive yet. So let's unselect this one, Let's select this one. And we're going to find g prime of 2, g prime of 4, and we're going to sketch the graph. So again, we have a couple different ways of doing this. Let's start by graphing the derivative. So we're going to come here down to y3. I'm going to go to math. I'm going to go down to n derive. The derivative with respect to x of, I go to vars, y vars, function, y2, enter. When evaluated when x equals x, and I can graph the function. So the red one is the function and the blue one, or the black one, is the derivative. So if I wanted to find the derivative at any point on this function, I can just go to trace, and I don't want to trace the red one, that's the function. It'll tell me the value of the function. I want to find the value of the derivative when x equals 2 is 4.000. And if it's asking you to go to 3 decimal places and there's more, see how this isn't just 4, but it's 4.0000173, I would put 4.000. I know it seems ridiculous, but that tells us that those are the first 3 decimals and that there is more, okay? That it's not just a plain 4. All right, now we trace, and we make sure we select the black one, and we want to do the derivative when x equals 4. 0.615. So those are the derivatives. Now if we needed to sketch the graph on our paper, you can go ahead and sketch the graph in that box. You can use a different zoom on this one. There's zoom 4, which is zoom decimal. And basically what it does is it goes from negative 4.7 to 4.7 and negative 3.1 to 3. And basically just what it does is it's really nice for things that change a lot in like increments of 0.1. So it zooms in just a little bit without zooming in a lot. So that's another zoom that you can try to look at this one a little bit better. It definitely gives us a little bit better ratio there. Okay, and then the last one, it asks if f of x equals absolute value of x, find f prime of 0. So you're like, cool, we're going to go to my calculator, we're going to go here, we're going to clear out all these functions, and we're going to do absolute value of x. And then we can go, remember this is another way to find the derivative. In fact, it's probably the best way to go to math and derive x with respect to x, and then we go to vars, y vars, function, y1, when x equals x, and it tells us the derivative is 1. Is the derivative 1? This is one of those instances where you are smarter than your calculator. You remember when people put in like negative 2 squared into their calculator and they tell me that negative 2 squared is 4 because their calculator told them to? Let's think about this. That's what the graph looks like. What is the derivative of that graph at 0? It does not have a derivative at 0 because it's a sharp turn, right? So our calculator is not smart enough to recognize sharp turns. So you have to recognize that there's a sharp turn there. Okay, so you have to know, oh, in the absolute value there's a sharp turn. So even though the calculator told me there's a derivative, there is not a derivative at a sharp turn. So that's one of those things that you just have to kind of pay attention to. And there you go. That's how you do it with a calculator.